So, hey everyone, my name is Zaubermann. As mentioned, today I will speak about API security. API security, divide and conquer. I have no idea how to pronounce. I just wrote it in Polish. I hope it's correct. So basically, I will speak today only about API security and OWASP top 10. So all the OWASP top 10 from API security you will see today. Hopefully I will manage and I will have enough time to do also a live demonstration about how to hack, or not hacking, but kind of how to abuse an API in a way that, like, changing stuff on the background, how to fix it, and how to really find a problem when we write the code. So hopefully I will get to it, but first, before we move into the live abuse, I want to go with you over the OWASP top 10. So, like, the most common, the top 10 common issues, like security issues we have within API. All right. So let's start. Maybe quickly about myself. I live in Germany. I'm Israeli originally. I'm working with Checkmarx. Checkmarx is like a static application security testing platform. Basically, what you do with Checkmarx is you take your own code and then you throw it into an engine, which gives you the vulnerabilities within the code. So it's like scan the code, check for vulnerabilities, and give you the results. I have more than 10 years experience in different fields of cybersecurity. If it's automotive, I worked in Volkswagen before for 2.5 years. I was doing penetration testing and reverse engineering of cars and like ECUs and stuff inside. Many things happened in the past, and then that brought me to really have a lot of information, a lot of knowledge within the cybersecurity field, and of course also IT. Today with me also, he will not speak today, but today with me I have kind of someone that you can relate to. He's Checkmarx regional sales manager. So if you have like questions and you don't, I don't know, if you feel comfortable with the language or something. Unfortunately, I don't speak any Polish or Czech or something even similar, except of Jaish and Dziękuję. Basically, you can approach Chez, and he will be happy to answer a question or transfer it to me or whatever. Would be nice. So what do we do? What Checkmarx is doing is we basically integrate security into the DevOps cycle or into SDLC, whatever you name it. And we start by, we scan, as I said, we scan the code, we check for open source vulnerabilities, etc., etc. This is our technology. I want to go over it quickly just for you to understand and where we are coming from. And basically, our topic today is API security. So let's dive in. So API stands for Application Programming Interface. I guess you guys, hope most of you are also already aware about API. But to take the most, the easiest definition is an interface to or communication protocol between a client and a server. That's like the base definition of API. What is actually using APIs? Where do we use APIs? We use it between microservices. We use it in mobile application, in IoT, B2B application, serverless application, in the cloud, in automotive, even single page application. You know, we love APIs. We know it's everywhere. It's nice. It's easy. It's approachable. So very fast as well. And yeah, and when we speak about API, we also need to secure it. The thing is that most of the time, the problem with API, with security, is that we invest a lot in security, but at the end we forgot some things within the API. And I think if someone is really, like, from budget-wise as well, if someone is really into investing in API, he doesn't need to invest so much budget. It's more about the work that you need to invest. Okay, it's like 90% of or it's like a configuration and misconfiguration and I don't know, removing all the like API ends and stuff like this. All those things. It's something that usually it's a lot of more work than money. Okay, it's like That's basically it. So our agenda today, how API-based applications are different. Then I will go to each one of these. Oh, happens fast. I will speak about the OWASP API Security Top 10. So I will go one by one. Very nice with animation. I did it so it will not be super boring, and you can really understand each one of the issues we have of the domains, right? API 1 to 3. And if I will have enough time at the end, I will show you a live API abuse on a combination of API 1 and API 5. Sounds good? All right, so let's start. How API-based apps are different. So client devices are becoming varied and stronger. We know it. The logic move from the backend to the front end. We see, of course, if it moves from there, then we see a lot of vulnerabilities that are coming from the backend to the front end, of course. And this is like if we speak about traditional APIs, we see basically this architecture. So the traditional application communicate to the server with a GET thing. All the rendering, everything is happening on the server. Bring back an HTML, rendered HTML, and then you show it to the client side. But when we speak about modern application, it's not like that. I guess most of you also are aware about it. We send an API GET. We send back a raw JSON or whatever, and then all the rendering and most of the things are actually happening on the client side. It doesn't matter if it's an Android device, if it's an iOS device, it's a whatever web-based client, browser, etc. So we see less layers, less, of course, abstraction layers. We see most of the things are everyone speaks JSON suddenly, right? If it's the rendering, if it's the server, if it's the database, etc. Those things are most of the time we see it now these days with JSON. How API-based applications are different. So yeah, I just look at the watch that we seem to have enough time. I go over those things like really fast so we can really, I guess most of you are already familiar with it, so we can get into the security point. But it's just for the people who are a bit or just started the way. So the REST API standard, it's standardized, it's generic, there are predictable entry points, right? You will see at the end what I mean by predictable. And there is one entry point, which is the URL, and it can be also used for multiple processes, right? If we want a function, if you want to, I don't know, get a user or call a function or whatever, those kind of things we see, we can do it, of course, with API. What about DevOps, right? We want to integrate APIs. We use a lot of APIs within DevOps. It's just a few clicks, you know, within your CI/CD and everything. You have like 100 of API hosts, like in a second. It's easy, and of course it's super fast. Okay, but how fast? It's so fast that we basically forget to. It's so hard for us to track it, right? It's like there are shadows API, things that we forgot, like all the exposed APIs that we forgot. We put it there on the back. We did it just for testing or whatever, and then we forgot about it completely. And then it's still there. People can actually still access it, although it gives us a lot of information, right? So we will speak about it on the API OWASP Top 10. How API-based apps are actually different. So the good news is that traditional vulnerabilities, like we saw on OWASP Top 10, right? The normal OWASP Top 10, if you guys are familiar, they are less common in API-based applications. Things like SQL injection, I guess you guys are aware about it, or CSRF, or path manipulation, right? Those things we see like classic IT security stuff, security problems. Those things we see less in API, but therefore coming other vulnerabilities that we see that are happening these days within the API. So we have the API OWASP Top 10, and then after that came we need to bridge basically the gap, because we saw that it's a bit different than a normal web application. We cannot take OWASP Top 10 and start working through the domains there without really having the understanding about like API security. It's a bit different, right? So how do we bridge the gap? We basically OWASP came up actually together with Checkmarx. They came up with the OWASP API Security project. It's kind of a joint venture between Checkmarx and OWASP. And we created together the API Security Top 10. It's already out. So if you guys want to go to OWASP and you can just write OWASP API Security Top 10, you will get them. You will have some cheat sheet, the same as you have for OWASP, normal OWASP Top 10. You also have for API Security. So basically, these are the 10 domains. Some of them you know, some of them less. You can see that injection came from one. You see injection here. It came from 1 all the way from 1 to 8. I will explain why. But you can see some changes and some things that you're not familiar with or less familiar with. And now we are going to dive into each one of them. Hopefully, I will manage to explain to you in a good way. So let's start, okay? So BOLA, what is BOLA? Broken Object Level Authorization. That's the first domain. The first domain basically tells us, hey, user, this is our user, and the user wants to get a document which the number is actually 1000. Okay, so he said, yeah, it belongs to you. You can see that it belongs to this user. Then everything is okay. But what happens if you change the number from 1000 to 1002? And then the server say, yeah, we don't check we didn't check specifically for this document that it belongs to you, but on the API, on the background, everything is fine. We give you back the document. It happens, we see it a lot, and that's why it's number 1, because you can basically get a lot of I don't know, information and documents that are actually happening, and it happens a lot, and you can get it in a wider surface. So attack surface is basically wider. Why? Because you have one user that can get information. We heard about all the leaks that happens, I don't know, from Facebook, from whatever, lots of things. I will show you now a few examples of it. But you can see that there is, but it's enough that you have one point of failure that happens. Someone finds one point of API that he can do, I don't know, 1 million calls, and then he can download all the information. Download, yes, just I don't know, get it in JSON, and then I don't know, CSV, whatever later, these kind of things. We see here all these leakages that happened actually with BOLA, with this broken object authorization, level authorization, yeah. So you can see from Verizon, you can see accessing 2 million Verizon Pay monthly contracts. So basically, you manage to get one document like the contracts from Verizon of all their customers, and you can see that the guy that found it, Delay B. You can see his name here. After a quick check, I learned that whatever this number, huge number, was the lowest contract number that could be viewed. So basically, what he did, he checked from he downloaded all the contracts from 131000 until 999. Right? He just created this, I don't know, Python script, and then he managed to get down all the to download the entire contracts from Verizon. Okay. It happens, and it happens a lot, okay? Another thing, actually, I think it's a Polish guy, this guy, Daniel Rekwek. I have no idea if I pronounced it right, but I read this guy's full disclosure from Skoda, actually. It was from Skoda. And the guy was actually sniffing around the Skoda and the backend, like between his own Skoda and the backend. And he managed to obtain all the car's ID, VIN. As you can see here, it's called VIN, Vehicle Identification Number. And he managed to get like the vehicle health reports of all the fleet of Skoda. Like you can basically request any vehicle report from any VIN, and then you get a report of the mileage, as you see here, and like timestamps and stuff like this, etc., etc. You can see even like if it's white or red or whatever. Okay, so very interesting stuff. And BOLA, we see it a lot, and that's why it's number 1. API 2, broken authentication. So we have, why broken authentication? We have things that we need to protect, and we do kind of a threat modeling, okay? The threat modeling, there are things we need to protect. So what kind of API we have? We have forgot password, login, mobile login, update location, and edit photo. This kind of things, this kind of function or whatever you call it, this kind of function or methods actually are being like the assets we actually need to protect is like if it's update location, maybe it's less risky than login, right? Login is like the top security issue. If someone managed to bypass the login, then screwed, right? So so we need first of all to make sure that we protect the right or the relevant assets. So we put an extra protection on the relevant asset, and of course rate limiting. I see a lot of APIs that you can just send thousands of requests in 1 minute, right? Or in 1 second even if you put like multi-threading, right? You do multi-threading with 100 or 1,000 workers just going and fetching information, and you should rate limit your request. That's one thing. And second is like the extra protection, things like, I don't know, lockout mechanism, CAPTCHA, credential stuffing protection, etc., etc. Those kind of things are super, super important on the implementation, and that's why and these kind of things are we see also a lot. Things like misimplementation, okay? So we have or lack of protection or misimplementation. And those misimplementations like no validation of OAuth provider. So if you did OAuth, so use the token or JWT or whatever, use the right algorithm, use the session, okay? Create a session, use the session with every single request. Don't forget those things. Solve the password, whatever, those kind of things, you know, just try to see that you do the things by the protocol and not like by the security protocol if you guys have, or by the security policy, but make sure you use those things, okay? So why is it so common? We see it a lot in, as I spoke about, like with OAuth isn't authenticate. Basically, OAuth is not an authentication. You should use maybe some other thing. Maybe there are a lot of things to implement there. But the idea is, you can see it here from the multiple authentication flows in modern applications. So you can see like, we can see it in IoT devices, okay? I checked an IoT device. I think it was a Portuguese company that has kind of a door lock mechanism. And like, so you can use it with Airbnb. Maybe you guys are aware about it. And these kind of things, you see all the requests that happens, you know, it connects to the Wi-Fi within the apartment. So I just managed to like, I got the apartment in Airbnb, and then I managed to connect to the door lock. And then you can see then all the door locks that you have in the apartments. And I managed to open all the apartments within the door, like all the door locks of the apartments, because it's only like a keypad, or you can actually do it from your phone. You can open the door from your phone. So those kind of things you can see a lot, and like, there was no authentication between the door locks, right? It was only one authentication that you do, and then you have access to all the door locks. So it's a bit funny. Excessive data exposure, super important, super important. I see this one, I don't know, maybe all of them are important, but this one is something that you basically give too much information to the client, right? Basically, what here we need to see super safe app. It's Bob's profile, the name, the role, like Bob's role, and then his hobby. But what happened is that we send a get request. This get request 717, probably it's the profile of Bob. And then what we get back, we get, yeah, okay, you got 200, everything is fine. Everything is fine. And then you can see that what we got some address here. Where is the address? We don't see any address. User ID also we don't see, or you know, the only thing we see is the role, the name, and the hobby, right? And of course the JPEG of Bob. That's what we see. But why do we need to add the address? Okay, the address is something that is not mentioned here, and we didn't render it on the client side. So this is something that that's what I'm talking about when we speak about excessive data exposure. Okay. Filter those sensitive data, send what you need to send, and not more than that. Why is it so common as well? REST standards, API economy encourage developer to implement API. You do it in a generic way. Try to do it more specific. Use of generic functions like to JSON and then you send, right? You know this one, just a to JSON method and then send it back. For example, for API 3, I have a small example for you guys. It's called TreeFun Hack. Okay, TreeFun is an application that it was found by Pentest partners, by Alex Lomas. He found, he just took a look at this application. I think this application basically find you a partner, like it was like Ashley Madison, kind of like a partner for married couple or something like this. And then if you look at the background, this one is Burp, by the way, the tool. And if you look at the requests, then you can see that you can see all the match users that you have. You can see their location, like their current location, because it's based on location, like who's around you, kind of Tinder-wise. And then if you look at it, then you can actually go and download all the location of all the users and just changing the number on the top. And then here, for example, he showed that you can see some people in the White House looking for a match there for, you know, married couple looking for match, for example. So we see those things are happening all the time. Lack of resources. How long do I have? 20 minutes. Okay, we have 20 minutes. Let's try to get maybe 30. Okay, lack of resources and rate limiting. We spoke about it, the rate limiting, but just make sure that you have enough memory that exposed to the web, use of limit like of the request of like files. There's no way that one person downloads 100 files, right? Just put those kind of limitations and stuff like that. Make sure that the strings are not too like the strings that you said, like for example, if you do it by comma separated value, like kind of CSV, or by comma, you separate those things. So then like the request, you know, like if you send a request and then there is like user 1, user 3, user 4, user 10, user 20. Okay, those kind of things, and then you separate it. Make sure that there is a limit to this one. Okay, so not like 1, 2, 3. Maybe try to do up to 5, or something that you really use at the end on the client side, and not something that you, I don't know, just give, I don't know, 100 or 300 users at the same time, or something like that. Okay, or requests at the same time. And of course, it opens you to brute force attacking, credential stuffing, denial of service, something that happens a lot. This one is actually really interesting. My live abuse will be on I think on BFLA, a combination of BFLA and also the first one of BOLA. Basically BFLA mean that if we have a normal admin, okay, the admin is sent a legit delete user number 717. You remember from Bob from the Minion? Number 700, user 717 deleted. Okay, no problem. But then what happens if some regular user is sending a delete request to 717? That's something that cannot be done, right? It needs to be, maybe you are laughing now, you say, yeah, for sure, who's doing it? Believe me, you have it. It happens all the time. I see those things all the time. Okay, so it happens, and just, you know, here it's only, I'm coming here to show you that how to avoid it, and that exists, and how to avoid it as well. Okay, so why is it so common? Function level authorization can be implemented in different ways. You can do it in a code, right? I will show you how to do it later within the code, with configuration, with API gateways that manage all the configuration for you, and the idea is, like we spoke about, predictability of the like how to predict what would be the request, the path request, right? So in traditional apps, we see the endpoint are like something like that, right? So it's like get up user ASPX user ID, this parameter here, the user ID 1337. And then it's not easy to predict that the action will be, for example, delete. Action equal delete and user ID, blah blah. It's a bit hard to predict. But what about APIs? API is super easy. Instead of get, you have get API v2 users 1337. You just change it to delete, and everything is fine, right? It's that's the request. That's how API works. So it's super predictable to do, to understand, to see how it works, and that's why broken function level authorization is happening a lot. Mass assignments. Mass assignments is things like, this one is also part of my live abuse. It's like, you can see that the username, like the thing is that you can basically get more information. It's like a combination of the sensitive data exposure and as well assignments of specific roles like we see here, or assignments of specific parameters on top of this post request, right? So if we have a user new like Bob and his password, then it cannot be that it would be super easy just to add the role admin and then you become an admin. But we see it, and actually the API that I have here to show you is actually using it, okay? Normal C# API, you will see. Okay, so you can see that there are some sensitive parameters, and just make sure that you really use that it's not so obvious, and that actually no one, like a normal user, cannot become an admin, right? To do for himself privilege escalation just by sending another JSON, which his role is becoming administrator, right? It's easier to exploit an API, and we can, it's with mass assignments, and you will see now what. We speak here about to become like privilege escalation, but what about remote code execution? So for example, here I have a GET request for some video file, and you can see here that we have a video file that is being converted, right? It's being converted to some Kodak, whatever, okay? H.264, I guess you guys also heard about it. And then if I do an update or put request in this one, then what I can do is actually conversion parameters. I can do -v, right? It's something that is going to be executed. -v is some kind of execution, right? You can see it's -v codec H.264 and format C. What happened here? You know, not pleasant at the end. On the background, yeah, it wouldn't be pleasant to the guys who wrote this this API. So you got the idea. Security misconfiguration, something that we see also, we see a lot as well. It's like weak encryptions, unnecessary exposed HTTP methods. It's like put or delete or whatever. If it's not there, if you don't use it, don't use it. Okay, like make sure that it's not even acceptable by the server. No CSRF protection, that's fine. We see it less today with API, but still. Detailed error messages. Also, when you send back an error message, if it's written in JSON, then that's fine, but just don't give too much information when you send the error, okay? Keep it in the log, leave it to the, leave it to the other, leave it to the logs, leave it to the guys that are actually going to do something with this error. What you present to the user is like, I don't know, your password is wrong, that's it. Or credentials are wrong. I wouldn't even write the passwords wrong. I would write credential wrong or something. Okay, so so don't give them too much information. Okay, only what's necessary. I move on because of time. Injection. Injection, it drops from, as I said, it drops from A1 to A8. Why drops? The main reason is that injection is currently #1 in 2017 in OWASP 2017. It's because of SQL injection. It's still #1 in OWASP top 10, but I think if you ask me, OWASP top 10 2020 is not going to be, SQL injection is not going to be so common. Hopefully, I hope. You never know. And SQL injection are not very common in modern APIs because we use object rationals mapping, like JSON stuff, and if we're increasing use of NoSQL, also same idea. So we don't see much SQL on the background, and that's why it's very hard to do an SQL injection within API. Okay. There is something that's called NoSQL injections, but it's not very common and also not very severe. Okay, so it's okay, it's still there, and that's why injection actually moved from What we saw before, by the way, with the injection of a code, but it was not actually the fault of the API, kind of, when we managed to format the entire C. It was the fault of the developer that actually managed to get there something. But it's kind of also injection. Improper asset management. So improper asset managers, like we have two similar issues, okay, or housekeeping issues. The first thing is lack of documentation. So asset management, you remember we spoke about right at the beginning. We have you know, a very old API function or method or whatever that someone forgot to delete when he used it. For example, things like download transactions as PDF or transfer money or whatever, something, export all users, like legacy stuff, things we forgot, blah, 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 and exposed risky API. So things like, I don't know, beta API or mobile API, you know, things that are super easy to guess as well. And not only that they are easy, it's also that they are open. And that's the most important thing. Why is such a big problem? Because API changes all the time. We have CI/CD, we need to deliver fast. Usually, you know, everyone likes to develop, no one likes to document. Even me, everyone, I guess you guys as well. So the document, okay, make sure that you document, make sure that at least you guys remember what you did and all the legacy, and that you remove it, that you won't forget about it in the future. We have lots of cloud deployments and automations that are happening on the background, and it also makes us to forget, you know, like, yeah, you spin in like another API, okay, we forgot the other API, we put it at the side. Things like, you can see here, things like, I don't know, QA stuff, right? QA3all.app.com. What is it, guys? Like, someone is using it, and I check it a lot, you know, I see also lots of like subdomains that you look for, subdomains that are registered. You find those kind of things and you say, okay, that's perfect. Like, that's a great attack vector for me, okay? So just make sure that you remove all those, I don't know, environments that you haven't used, test environments, whatever, and that it's not really work at the user side or at the client side, okay? That it's not like open. We are good in time. Insufficient logging and monitoring. This one is API 10. It's number 10. It's also, by the way, if you remember, it's also number 10 in top 10 as well. You can see here, top 10, insufficient logging and monitoring. And I think it will stay there forever because we still don't do any logs. Okay, as I said before, we spoke about it. Take the logs, throw them at the back. It doesn't matter what. Put a timestamp, put something happen, warning, whatever, error, anything, just put it at the back, you know. Then later, if something happened, if there was an attack or there was a hack on the application, then at the end you can actually go back and forensic it, right? So you can trace back what happened, you know, you can investigate, you can say, okay, this one, it happens because 1 and 2 and 3, you can see exactly what happened. Throw logs, you know, we have enough. It's not like we're not in the 1970s, so we have enough memory, enough storage, everything is fine. Just throw everything to the back. We will have enough memory for it, right? That's basically it about API, about the API's OWASP top 10. I still have time for the live abuse, which is cool. I have another like 10 minutes. So basically what I'm going to do now is I have here an API that works, okay, that like now it's running on the background. I can show you, let me show you here, right? Yeah, this one is the, you can see it's written in C#, okay? By the way, if someone didn't recognize this, yeah. So if someone didn't recognize, that's C#, by the way. Just a small game. So what I'm going to do is that I'm going to show the abuse, how actually you can do it, okay? The server is currently running. I'm using Postman, maybe I will use Burp, I will show you later, but basically it's a damn vulnerable C# application with the API. It's called DV C#. You can go to GitHub and play with it a bit. The architecture of this application goes like that. You have You can basically do requests from any client you want. I'm using here Postman. And you have like delete, you have put, you have get. You can actually download the entire, I think they have like the entire core API that you can use there later. And then, of course, it goes to the application server and HTTP request, you know the drill. Okay, so basically what I'm going to do is like I registered already 4 users. So if I go here to the list of the users, you can see that I have, can you see it? I hope you can see it. So maybe now. So if you look at it now, you can see that I have 4 users, or maybe here 6 in my case. So you have like user 1, which is a role administrator, right? I just did like with an administrator token. I used like a list users get. And then you can see like I have user 2, user 3, user 4, right? User 2, for example, is just a role user. Okay, so what I'm going to do now is I'm going to get a token for user 2 just to see if I can, like, to see what I can do. Okay, so let's take this one a bit here. Yeah, perfect. So I will go to do an authorization from user 2. So let's look. User 2 has user2 at user2test.com. Okay, so I have here user2test.com. I see that the role is right. It's a post request. This is the body. I do like an authentication or authorization request. I get the token. Here I have the token. Very nice. I take the token here and I want to update my user. Right. This is my user 2. I want to update my password to be I don't know, new password 1 or whatever, new password now. Okay, that will be new password. And then if I will go and I will do send, it will give me unauthorized. You can see here 401 unauthorized. So I will go to the parameters. Sorry, go to the authentication. I will put here the token. I will go back to the body. I will see that everything is fine. Send. Okay, the role field is required. So I need here a role field. So I will put here. If I have it here, yeah. So I put here a role field, which is user. Okay, let's try now. Okay, now it's go. But now you remember what I did? Let's change it to administrator. I do send. Oh, the role is now administrator. Everything was okay. I did like with 2. Now, actually, after I put myself in administrator, let's try to, I don't know, let's try to look at the list of the users now. I can see all the users now. I'm an administrator, right? I used the token of number 2. So everything is fine now, and user 2 is an administrator. Okay, so that's basically it. I can actually go here and say I want to update somewhere else, right? Like an update of someone else's user, right? Or I can delete the user. You can see here delete. I can delete user number 1. Now the administrator that was before, I can delete it, right? So if I go here to authorization, I put here barrier token. I put this one. I say delete. Oh, deleted. Created it, updated it, and then it's deleted. Okay, so you can see the problem with APIs. It's super fast, as I spoke before, and it's also very easy to, you know, if you forgot something small, like, I don't know, checking that the user is actually an administrator, then it's a problem, right, in the code. So you can see here, we saw the user. We basically moved over, like I did an update an unauthorized user. We saw that I managed to privilege escalate myself to an admin by just changing the role of the request behind. Here we see it like nicely because it looks very nice. But at the end, you have a web application, like a web front end that is doing everything. I just look in burp on the side and how it works, and then I realized that I can change my role. Right, so that's how it works. So basically, what you can do with the check marks, we check also, or we scan also for API security. So the top 10 we have, and you can see here on after I scanned with check marks with checkmark SAST with the static application security testing, right, from the source code. I saw that there is a problem here. Maybe you don't see it good, but I see that there is some kind of missing object level authorization. So I see there is an authorized, But if I look at it like better, I see that there is no like here it's a put request. You can see here it's a put request, but I see that there is no there's no like check that I did that I do the put request that the ID that I'm coming from. First of all, it's the same ID, right? That's the first thing that I check here, if it's the same ID. But I don't check if it's an administrator role before I even doing the update, right? That's the first thing. And second, I don't even check that if it's my own ID. Okay, so these are the things that I'm checking here. And then you can actually assign a role. Here, you can assign a role just from the, like, that's the second problem that we showed now. It's like assign a role without being an administrator, right? That's the problem. So now if I actually, that's the code, okay? That's the backend code. So if I actually now look at the code, that was the code before, so you can see the MID, whatever, and then now I put some more, you know, some more if statements and saw exactly what happened and like managed to create a bit more. And I say, first of all, I take that it's, first of all, I want to check that if the ID that is doing the update is actually his own user and not someone else's user. That's the first thing I want to check, right? It's this if, right? Let me quickly mark it. I don't know if you see it, but it's this if statement, right? So I first of all, I check that the ID that I'm currently changing is the ID that I'm currently changing. And second, or the user that I'm giving is actually an administrator, right? Like if it's an administrator, okay, go ahead, you can change whatever user you want because it's an administrator. But if it's an ID, then it's only an ID, and that's the only thing you can check. Okay, so this is, for example, just it just solves us one, but I guess if you guys are a bit aware about like just have a single knowledge, like a bit of knowledge even about regarding programming, you can understand that quite fast. So now I rescan, okay, I fixed the code, then I rescanned it. You can see that I fixed the code, I rescanned it. I basically returned forbid. And then you can see that also, if we look at it back here, we saw that we found two problems, right? And then I rescanned it with check marks. Now I have one because the put request I scanned, okay? So the only thing I still have here is the delete request or whatever. And that's about it. So API security, vulnerability detection, REST APIs, that's what we spoke about right now. Supporting OWASP, so as I said, checkmark, supporting OWASP top 10 API security, the ability to detect vulnerabilities regardless. It's very hard when you have so many APIs, so much code and stuff like this. You need to have a tool which can also help you to, you remember with the CI/CD, we want to deploy fast and super fast, but you still need to make sure that you integrate the relevant tools within your, doesn't matter if it's checkmarks or whatever, right? The idea here is just to implement tools that will help you automate your security as well, not only automate your deployment, right? It needs to be together. And of course, you can see like focusing on API security related vulnerabilities. It's not only, of course, we have other things that we like, I don't know, other security issues, not only API. Main takeaways, supporting detection of API, everything can be found in the code, okay? It's nice to do Dust. Dust is basically kind of penetration testing. It's nice to do Dust, but at the end, if you look at the code, you can find things super easy and fast. And also, you write the code, you deploy, you check it, it's still not yet live, kind of. Yeah, it's like a checkmark is like the leader of API because checkmarks did like a venture together with OWASP top 10. So you can really understand, we really understand API security, and we can implement it quite good with the checkmark Soft. Best practice for secure development, that's super important. You have automation, training, like try to automate, right? To automate the security process. Training, take some training on API security. You guys can go and check for code bashing. It's a great tool. I guess some of the courses they're also for free. So check code bashing. You go there, you can see API security. and you can learn a bit more about API security and also other things like other thousands of languages that you have there for security. It's like a platform to train yourself for security coding. Evaluation, carefully shopping, right? What you do with which security tools you are buying, just don't buy any security tools, of course, just make sure that it really fits you. CI/CD, 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 we know the drill. Open source, very important. Scanning all the time to do the scan, and of course integrated within the SDLC. That's the best practices that I have. I would put a lot of effort on the training and on the automation. That's where I would put most of my, automation and scanning. Okay, so that was my presentation. I hope you guys enjoyed. Dziękuję. Yeah, I'm open for question now.